Chapter 4. WHMIS Hazard Classification. Classification. Hazard classification under WHMIS 2015 is a rigorous, science-based process that forms the foundational step of the entire system. It is a mandatory requirement for suppliers dictated by the Hazardous Products Regulations, HPR. The process involves identifying the intrinsic properties of a chemical substance or mixture and determining the nature and severity of the hazards it presents. The outcome of this classification is not arbitrary. It directly dictates every piece of hazard communication that follows. Specifically, the assigned hazard class and category prescribe the specific pictograms, signal words, and hazard statements that must appear on the label, and they trigger the required information that must be included in the Safety Data Sheet, SDS. This ensures a consistent and standardized approach to hazard communication across all products and suppliers, allowing workers to trust that a flame pictogram, for example, means the same level of fire hazard regardless of the manufacturer. Hazard groups. Hazard groups are the broadest categories of hazards. WHMIS divides hazards into two main groups: physical hazards, which are based on the physical or chemical properties of the product, such as its potential to catch fire or explode, and health hazards, which are based on the ability of the product to cause adverse health effects in exposed individuals. A single product can belong to one or both. For instance, gasoline is classified for physical hazards, flammable liquid, and health hazards, acute toxicity and skin irritation. Hazard classes. A hazard class is a subdivision within a hazard group that describes the nature of the physical or health hazard. Examples of physical hazard classes include flammable liquids, oxidizing gases, and self-reactive substances.
Skin corrosion or irritation.
Examples of health hazard classes include acute toxicity, skin corrosion or irritation, and carcinogenicity. Hazard categories. Once the hazard class is identified, the hazard category is assigned within that class. Categories indicate the severity of the hazard, with Category 1 representing the most severe level. For instance, within the flammable liquids class, Category 1 is for highly flammable liquids, while Category 4 is for combustible liquids with a higher flash point. This categorization is critical as it determines the specific signal word, danger, for more severe categories, warning for less severe ones, and the exact hazard statements that must appear on the label. And they trigger the required information that must be included in the Safety Data Sheet. How does WHMIS classification work? The WHMIS classification process is a systematic sequence designed to ensure accuracy and consistency. It can be broken down into 3 critical steps, each with specific criteria based on scientific data from tests, literature, and practical experience. The classification process follows a logical 3-step sequence. First, the supplier must identify all applicable hazard groups, primarily physical hazards and health hazards. Second, within these groups, they assign a specific hazard class and category. Finally, based on the assigned hazard class and category, they determine the exact label and SDS content that are legally required to communicate the hazards effectively. Identify applicable hazard groups. The first step is to determine which of the 2 broad hazard groups the product falls into. Physical hazards are based on the physical or chemical properties of the product, such as its potential to catch fire, explode, or react violently with other substances. Health hazards are based on the ability of the product to cause an adverse health effect following exposure, whether through inhalation, skin contact, or ingestion. A single product can belong to one or both. For instance, gasoline is classified for physical hazards, flammable liquid, and health hazards, acute toxicity, and skin irritation. Hazard classes. Within each hazard group, The product is evaluated against specific, defined hazard classes. A hazard class is the nature of the physical or health hazard. WHMIS 2015 outlines specific criteria for each class. Determine label and SDS content. The final step is to translate the scientific classification into mandated communication tools. The assigned class and category act as a direct lookup table prescribed by the HPR to determine the exact information that must appear. For example, a product classified as acute toxicity, oral, category 1, automatically requires the skull and crossbones pictogram, the signal word danger, and the hazard statement, fatal if swallowed. Similarly, this classification dictates what information must be populated in Section 2, Hazard Identification, and Section 11, Toxicological Information, of the Safety Data Sheet. This systematic approach ensures that the hazards identified through scientific analysis are communicated to the worker in a clear, consistent, and unambiguous manner. Physical hazard classes. The main concern with physical hazards is their potential to cause immediate harm through the release of energy or violent reaction. Flammable materials pose a significant risk of fire and explosion. Gases under pressure can explode if heated or damaged and may cause cryogenic burns or frostbite. Oxidizers may not burn themselves, but can intensely fuel a fire by providing oxygen. Physical hazard classes are broken down into several subcategories: flammable gases, aerosols, liquids, and solids. Classification is often determined by flash point and boiling point for liquids. A flammable liquid with a flash point below 23 degrees Celsius and a boiling point below 35 degrees Celsius would be placed in the most severe category for that class, for instance, Category 1 for that class. Gases under pressure. This class includes gases that are compressed, liquefied, dissolved, or refrigerated. The hazard is primarily physical, potential for explosive rupture, and classification is based on the physical state and pressure. Oxidizing gases, liquids, and solids. These are tested to see if they, by yielding oxygen, increase the burning rate or intensity of a combustible material. Health hazards. Health hazards cause adverse health effects on the health of an exposed person. These effects can be immediate, acute, or develop over a long period, chronic. Key concerns include acute toxicity, which can cause poisoning or death from a single or short-term exposure, skin and eye damage, such as corrosion or irritation, and chronic effects like carcinogenicity, cancer, and reproductive toxicity, which can impact fertility and fetal development. Health hazard classifications, health hazard classes. Health hazards cause adverse effects on the health of an exposed person. These effects can be immediate or develop over a long period. The WHMIS 2015 system categorizes these into specific classes to clearly communicate the nature of the risk. Understanding these classes is crucial for recognizing the potential long-term and short-term consequences of working with hazardous materials. Acute toxicity. The acute toxicity hazard class covers chemicals that cause adverse health effects following short-term exposure. These effects, which can include poisoning, organ damage, or death, can occur after a single or multiple exposures within a 24-hour period. Routes of exposure include oral, swallowed, dermal, skin contact, and inhalation, breathed in. Classification is based on precise toxicological test data, such as the median lethal dose, LD50, or median lethal concentration, LC50, with Category 1 representing the most severe, potentially fatal level of toxicity. Skin corrosion or irritation. This hazard class addresses the ability of a chemical to cause damage or irritation to the skin. Skin corrosion refers to the production of irreversible tissue damage, visible as ulcers, bleeding, or scarring following application to the skin. Skin irritation refers to the production of reversible damage, such as redness or inflammation. The distinction is critical. with corrosives posing a more severe and permanent injury risk, requiring more stringent handling controls in personal protective equipment. Serious eye damage or eye irritation. This class covers chemicals that cause serious damage to the eye or eye irritation. Serious eye damage involves tissue damage or vision decay that is not fully reversible. Eye irritation involves changes to the eye that are fully reversible within a 21-day observation period. The corrosion pictogram is used for chemicals causing serious, irreversible damage, while the exclamation mark pictogram is often used for reversible irritants. Respiratory or skin sensitization. A sensitizer is a chemical that, after repeated exposure, can cause an allergic reaction. Respiratory sensitizers can lead to hypersensitivity of the airways, resulting in conditions like asthma. Skin sensitizers can lead to allergic contact dermatitis. Once a worker becomes sensitized, even very low subsequent exposures can trigger a significant and harmful reaction, making it essential to prevent initial exposure through proper controls and PPE. Germ cell mutagenicity. This hazard class includes chemicals that may cause mutations in germ cells, which are the reproductive cells, sperm and egg. These mutations can be passed on to future generations, potentially leading to hereditary diseases. Mutagens can cause changes to the structure of DNA, and this class is subdivided into categories based on the weight of evidence that the substance can cause heritable mutations in human germ cells. Carcinogenicity. A carcinogen is a substance or mixture that is known or suspected to cause cancer. Cancer is a complex disease characterized by the uncontrolled growth and spread of abnormal cells. WHMIS classifies carcinogens into two categories. Category 1 for substances known to cause cancer in humans, and Category 2 for substances suspected of causing cancer, typically based on animal studies. Exposure to carcinogens may not cause immediate illness, but can result in cancer many years later. Reproductive toxicity. This class covers chemicals that have adverse effects on sexual function, fertility, and development of offspring. Reproductive toxicity includes impacts on both male and female reproductive systems, as well as developmental toxicity, which is damage to a developing fetus. Effects can include reduced fertility, miscarriage, or birth defects. This class highlights hazards that can affect not only the health of the worker, but also the health of their future children. Specific target organ toxicity single exposure, or STOT single exposure. This class covers specific non-lethal target organ toxicity arising from a single exposure to a chemical. A target organ is a specific organ, for example, the liver, kidneys, nervous system, lungs, that can be damaged by the chemical. STOT single exposure refers to effects that occur rapidly after a single contact, such as liver damage from a solvent exposure or narcotic effects from inhaling a gas. Specific target organ toxicity repeated exposure, or STOT repeated exposure. This class covers specific target organ toxicity arising from repeated exposure to a chemical. The damage occurs gradually over time as the substance builds up in the body or the effects accumulate. Examples include liver cirrhosis from long-term alcohol exposure or lung disease from years of inhaling silica dust. This class is critical for understanding the chronic risks associated with daily handling of certain substances. Aspiration hazard. Aspiration refers to the entry of a liquid or solid chemical directly into the trachea and lower respiratory system through swallowing or vomiting. Aspiration hazard is the potential for a chemical to cause chemical pneumonia, lung injury, or death after being aspirated. Hydrocarbons, like petroleum distillates and certain solvents, are common examples. The hazard is particularly severe because a very small amount, as little as 1 teaspoon, aspirated into the lungs can be fatal. Biohazardous infectious materials. This is a specific hazard class of materials that are organisms or toxins that can cause disease in people or animals. This includes microorganisms such as bacteria, viruses, fungi, and parasites. The primary concern is infection, which can range from mild to life-threatening. This class requires the Biohazardous Infectious Materials pictogram and is governed by specific containment and handling protocols beyond standard chemical safety. Health hazards not otherwise classified, or HHNOC. This is a catch-all category for health hazards that do not fit into any other specific health hazard class, but still pose a risk to workers. An example would be a substance that causes nausea or dizziness through a non-specific mechanism. While it is a miscellaneous category, it is still a legally recognized hazard under WHMIS, and the nature of the hazard must be communicated on the label and SDS. Conclusion. In conclusion, the hazard classification process is the scientific backbone of WHMIS. It is the method by which suppliers systematically identify the physical and health hazards of a product, categorize them by class and severity, and use this information to determine the specific content for labels and safety data sheets. Understanding that the specific warnings and pictograms we see are a direct result of this rigorous classification helps workers and employers appreciate the critical importance of the information provided and the need to follow the corresponding safety instructions without exception.